I won't get too excited, but if it gets this one right, if it converts that to yearly, I am just going to be very happy, because this is the sort of data cleaning that used to be really hard to do. And yes, there it is. It's automatically made that yearly. I am loving this. The interest in being a data scientist or an AI developer in 2025, you do not want to miss this tutorial. This tutorial is all about parsing unstructured data and getting structured outputs. And I'll give you an exact specific. So what we're talking about today is we've got some unstructured data that's actually a real estate listing. And inside that real estate listing, they've actually got a series of costs. In this case, they've got the strata cost, it's per quarter, council rates, and water costs as well. And if you look closely at this listing, that information is not listed anywhere else. It's only available in this text. Not all listings have this, but the ones that do, they're always written a little bit differently. And so today's challenge, we're going to write some Python that leverages local large language models. In this case, we'll be using Ollama. So if you haven't got Ollama installed, make sure you jump over to ollama.com, hit that download button. It's available for Windows, Mac, and Linux. Give that an install. And once you're in there, jump over to models, because what we're going to be using is, well, not DeepSeek R1, we're going to be using a much smaller model, Llama 3.2. The reason for that is Llama 3.2 does support tools which allows us to define really structured outputs which give amazing results when we're working from unstructured data to structured text. And I'm blown away at how well these smaller models, this one's 3 billion parameter, also available with 1 billion, how well they perform. Now, if your computer is a little bit older, a little bit slower, start with the 1 billion parameter model, see how it goes, then step up to the 3 billion. This is Llama 3.2. There's also Llama 3.1, which is available in sort of an 8 billion parameter model, or a 7. There's a few bigger ones. They get larger and larger as you go up. So 3.1 is what we're going to be working with. Now, to do that, what we're going to do is, we're going to install a Llama. We're going to jump into our terminal or a command prompt, depending on which system you're on, and run a Llama run 3.2. The next thing we're going to make sure is we've got to have Python installed on our local machine. So make sure you've got Python downloaded and installed. And next up, we're going to be using the Ollama Python package. Now, I've got a bunch of tutorials on my channel about how to get set up with notebooks. If you have any questions, drop a comment. But the reason I like Ollama is it does allow me to start with some basic boilerplate code. So I'm going to copy and paste this one. I'm going to pop that in here, and straight away we've actually got a working local large language model. So what I can do is I can quite literally hit the run button on this one. I'm going to clean this up a little bit, make it a bit simpler for us. Okay, so from Ollama import chat, and the chat object here just takes in the model. In this case, Llama 3.2, that's in the boilerplate code. And in the messages, they're just a list of messages. Each one is a dictionary. In this case, we've got a role called user, and it's got some content. We can also add in a role called system and give it a system sort of definition and give it some guidelines around what kind of system it is. I've got some videos on that as well on the channel. So if I hit run on this one, that'll take a moment because it doesn't actually stream. I haven't got streaming turned on. It's actually generating all the text. And here we have it. Now, why is the sky blue? And straight away, we've got a whole heap of information. But what we're interested in today is this particular real estate listing. So why don't we, for testing, grab hold of all this text, and you can imagine you've got thousands of these listings. Maybe you did some web scraping, you got thousands of these listings, and we'll use this one as a bit of a test. So we'll take a copy and paste of all, say, that information. And what we'll do is we'll give ourselves a bit of space. So we'll go, maybe give ourselves a bit more space here, and we'll call this one something like, just a variable called text. Give ourselves 3 quotation marks. It allows us to run this string across multiple lines. Paste on that one, 1, 2, 3, shift enter on that. And what we now have, I'll call it test, that's a bit silly. Now we have our texts, okay? So if what I can do is I can give ourselves a bit more space, and I can say, what does text equal? So let's go print text, scroll down on that one. And there we have it. So now we have this big body of text, and in here we've got these 3 charges. One is strata, one is council rates, and one is water. Now, the whole goal of this is how do we get structured outputs? So when we're looking at these real estate listings, we have this really structured data. We can then calculate and sum these up and then times them out by 4. So we've got them for the entire year, and standardize them. So some might be in weeks or months, probably months. Some might be in quarters. Some might be per annum or every 12 months, every year. So we need a way to standardize this. But before we get too carried away, let's see how well the local large language model can just return some JSON, JSON data, so a structured output that we can work with for this one. So what we're going to do is we're going to install a Llama import chat, and the chat object here just takes in the model. In this case, we've got a role called user, and it's got a list of messages. Each one is a dictionary. And in the messages, they're just a list of messages. We can also add in a role called system. And what we now have, I'll call it text. So if To do that, we're going to give ourselves, what are we going to do? So we're going to grab maybe this one here from Llama import chat, pop that at the top. That's nice and neat. And then what we're going to do is we're going to scroll down and we're literally just going to give this a prompt. So what we might do is we might give ourselves, where are we? So we'll give ourselves a bit more space here. And we'll create a prompt. And the prompt's just going to say prompt is equal to, okay, prompt is equal to f string. And the reason I'm using f string is I want to pass in that original text. And that prompt can be as simple as, so let's do 1, 2, 3, 1, 2, 3. Got one too many, haven't I? 1, 2, 3. Give ourselves a bit of space. And I did write something just earlier. So maybe what I'll do is I'll paste it and I'll read it out to you just to give you a feel for where my head's at. So my prompt is, given the below text, extract a JSON payload that outlines cost type, cost, and the period. And that's these ones here. So cost type would be strata. The cost would be 1,372 and the period would be quarterly. So, and I'm just saying here in a valid JSON, it is important to convert passage of time to weekly, monthly, quarterly, and yearly. Real estate listing text is here. So what that ends up looking like is if I shift enter on that one, what we now have is when I print out that prompt, you'll notice if I scroll up, we have the initial part of the prompt here that I just wrote, and then we've got a listing below and our text is still in there. So all we need to do now is we just literally need to pass that prompt into our Ollama chat, and we'll just literally, let me scroll down, we'll literally just take that and we'll paste it in, and we'll take that one out for a moment. We'll shift enter on that, we'll give ourselves a bit more space. And what we now have is we now have a response from this model. And the reason I'm not doing anything right now to really get strict around that JSON payload, I just want to see how well it performs. Can I pass this directly into, JSON sort of things? Let's have a look. Okay, so first observation, we have a bit of a preamble. Now we don't really want that, right? Because we want to be able to get this into like a Pandas DataFrame and output it into a CSV or a database. So we've got a bit of preamble, so it's not great. And then we've got some markdown saying this is JSON. So look, that's kind of useful. Then, I didn't even notice this. Then we've got this bit of prompting here, which is basically like in a more condensed format, and it's kind of got it again. To convert the passage of time to weekly, monthly, and quarterly, it's got some periods, and then it's tried to do a whole bunch of stuff for us. Now, this is great if I was in like a chat interface, but I want to automate this and set it up to run across thousands, if not hundreds of thousands of listings. So what can we do to make this a little bit smarter? So one thing we can do is we can actually go ahead and we can define something called a format and pass it a JSON schema. So give it some really strict rules around what we're actually expecting from this input data. So to do that, what we need to do is, well, I say we need to. Now, we don't absolutely need to use Pydantic. Now, Pydantic is an amazing data validation library in Python. It takes input data from external sources. In this case, we're sort of using an LLM, and it attempts to validate and coerce the data and do all sorts of cool stuff. So we'll be using Pydantic only because we don't have to write these JSON schemas. So let me show you exactly what I'm talking about. So what we'll say is from Pydantic, we're going to import something called BaseModel, okay? And that's going to be useful because in BaseModel, what we're going to do is we are going to be defining our cost breakdowns. Now, to do that, what I need to do is I need to create a couple of classes, okay? If you've never used classes before, we're going to be using them in a really simple way. We're just going to be using some class attributes, and I'll show you exactly what I mean right now. So we've got class, and class is going to be equal to something like I'll call it cost breakdown, okay? And this one here is all about those three values, okay? For this to work, we do need to inherit from BaseModel, which is this one here. So we're going to grab that, pop it in there. And then what we're going to do is we're actually going to define just three simple properties or attributes. One is going to be cost type. And the way Pydantic works is it works off type hinting. And all that means is I type in str, referring to string, okay? And now Pydantic knows that that's a string, okay? Next up, we've got the cost, and you probably guessed it, with cost, it's not a string, that's an integer, it's a whole number. And then with the period, for now we're gonna use a string, but we'll see how we go. We might upgrade that to something called an enum, which will allow us to give it a set of choices, like weekly, monthly, quarterly, yearly, just to get really strict around the values it's allowed to put in there, okay? Next up, we're just going to do one more class. And the reason for that is because if you look at this output, there is actually one payload there, another payload there, and another payload there. So we probably want one that says cost result or costs and actually outputs it. So the way that might look is something like this. So class, and we'll call this like cost results. That's also going to import from BaseModel. But the big difference here is rather than defining a type like string or int, we're actually going to pass in the cost breakdown. So let me show you exactly what I mean by that. So let's grab the BaseModel from here. Okay. And in cost, where are we? So, and then we've got, cost, we'll call it cost underscore result. Okay. And cost result, we're going to give it a type. Now it's going to be a list, and it's going to be the cost breakdown is going to be inside that list. So there is one extra thing we need to do. We actually do need to import the type list. So what we say is from typing import capital L list. And what we're going to say is now we're going to say, well, actually what we're doing is we're saying cost result is list. And inside that list, we're going to have a bunch of cost breakdown. Okay, shift enter on that. Now, all this has done is this has created two simple classes, because the thing we actually want to pass over to Ollama isn't actually these classes. It's actually the output of this class. So this one here, cost results, and it's the Pydantic feature called model underscore JSON underscore schema. Okay, shift enter on that. And this is the whole reason we are using Pydantic. It isn't for really Pydantic, it's actually just to automatically generate this thing. Now, I take that back. We are going to be using Pydantic to validate the outputs and do some cool stuff as well. But I don't need Pydantic for this to work. I need that. I need this JSON schema. So where to from here? Now, if we scroll down, let's quickly cut this one out. So we've got that in our clipboard. We're going to scroll down, and we actually are going to modify ever so slightly this little response here. What we're going to do is we are going to add in one more, one more little argument parameter. So format is equal to cost results dot model JSON schema. Now, remember, this is what the output looked like before, where it had a whole heap of text like we were in some sort of chat conversation. And if all goes to plan, this really should give us structured outputs every single time. So to make that work, shift enter on that. That's going to run. That's running right now. Give that a couple of seconds. Okay, that's finished. Now I'm going to shift enter on that output, and straight away, that is looking 10 times better. Straight away, that is looking really nice. Now, what we can actually do is we can actually validate that model. Okay, so what I mean by that, so what we can actually do is we can take something like cost results, righty? So cost results, and we can say something like model validate underscore JSON, alrighty? And what we can do is we can actually paste in the response here. So the response message content, which comes from Llama, pop that one in there, shift enter on that. And now what we have access to is this Pydantic object, which allows us to interact with this one in a really cool way. Because now what we have is we have these cost results, and within cost results, we have a whole bunch of cost breakdowns. Okay, so within cost result, we've got cost breakdown, cost type strata, period quarterly, and we've got the value there. Cost breakdown, cost type is cancel rate, and we've got the cost there. So where to from here? Now there's another really cool feature that we have access to. What we can do is let's go ahead, and rather than just having this one print to screen, we'll give it a name. We'll call it something like data. And so now that we have data, that gives us access to things like, for example, cost results. Okay, so shift enter on cost result. Sorry, cost result. What have I done wrong there? No, it's cost underscore result. That's my bad. So we have a look at this one. We've got here cost underscore result. Shift enter on that, and that gives us access to that list. And within that list, we've got each of those Pydantic. And we've got the cost breakdown. Cost breakdown is the class, cost type, cost, and then period. So what we can actually do from here is we can actually get that to a really nicely formatted dictionary for us to have a bit of a play with. So what we can do is we can then say something like cost in, data cost results. And all we're doing there is a little bit of list comprehension, so nothing actually changes. And then what we can do is we can actually run another Pydantic method called model dump. Okay, and within model dump, this now gives us access to all of these dictionaries. And whilst that's really cool, let's imagine just for a moment that some of our inputs were a little bit different and it wasn't always that consistent. So we may want to give it some more structure around the different types of values it can return. So this one here springs to mind. We've got this idea of a period, and that might be weekly, monthly, quarterly, or yearly. And so what we can do is similar to how we have cost breakdown, which is a Pydantic class, which is part of this list. We could do something similar, but for this to work, what we're going to need to do is we are going to need to use the Enum library. So the Enum library, as it sets out here, it's pretty straightforward. It allows you to have sort of set of choices, set of symbolic names, members bound to a unique value. It can get a little bit technical if you scroll down far enough, but the short of it is you can define an enum, you can define a class, import enum, and then you've got access to each of these values within that class. And that's really useful to Pydantic when you want to give it a set of choices. So you can only choose from these particular choices. So for that to work, it's as simple as saying we've got a class, and within that class we've got a period, and in there we're going to have string and then enum. Okay, so one is a string, one is our choice, and for that to work, we're going to make sure that we import enum. So we can say something like from enum import enum. Okay, that's that one there. And now that we have this period class, what we can do is we can actually define simple things like weekly. Okay, and that's just going to be equal to weekly, and you get the program. I'm going to fast forward this just a little bit, and I'll be back in a sec. All right, so I've got weekly, monthly, quarterly. I've done the string for each of those, and then all we need to do now is where we have period here, rather than asking for a string, we're going to say, well, no, return one of the enums, so one of these choices from the list here. So if I shift enter on that, and I shift enter all the way down, and I rerun, we don't need this prompt printing out anymore, rerun that one and have a look at that content. What we actually have access to now is we're sort of instructing the model to pick from one of these sort of options. Okay, so quarterly is coming up, and now if I run data and then model dump, you will notice that our period now is this enum, and that may not be that useful. And the good news is Pydantic has another feature, which I love, called mode equals JSON. So if we pop in here, we go model underscore dump, we can say mode equals JSON. Okay, pass that one in. Shift enter on that, and all of a sudden we've got a really nice list of dictionaries. And what I love about this is we can call this something like output data, okay, equal to that one. Scroll down, and now I can say something like, import pandas as PD, and then pd.dataframe, all right. And then within that, we can just say output data. Now shift enter on that one, and that's going to give us a nice little formatted table of our data. So cost type, the cost, and the period. Now the great thing about this is because we've defined those periods up here, the model is actually smart enough to select the right period, even if it's a bit weird. Okay, so let's go ahead and modify this data ever so slightly. Let's just say there's another bill called gas. Okay, and gas is, let's call it $15 we'll say per week. Okay, shift enter all the way down. Let's see how well it's performed at picking up that gas is $15 per week. Perfect. Gas, $15 weekly. Now, we didn't specifically say weekly, but we have defined weekly. The big test I want to know is how clever is this thing if I say per 7 days. Okay, we don't have an option for daily. We have given it some instructions here to convert passage of time. So will it go per 7 days is equal to weekly? Okay, let's see how well it performs. Shift enter all the way down on that. Okay, how do we go? Yep, nailed it. Love that. Okay, let's just keep testing this thing. Let's see if we can break it. Okay, what's next? Let's do gas at $740 per 365. Okay, this is actually going to be a hard one. Now I won't get too excited, but if it gets this one right, if it converts that to yearly, I am just going to be very happy, because this is the sort of data cleaning that used to be really hard to do. And yes, there it is. It's automatically made that yearly. I am loving this. Look, there's a lot of information to take in this tutorial. I'm very excited for where AI is heading, while the rest of the world is getting very excited about chat interfaces and, talking to AI. I think there is real value in being able to take unstructured text like this, spending a bit of time, so not just automating everything, spending a bit of time defining some very well structured data, using the technology to pass in formats, and then outputting really nicely structured data. Okay, one more test, okay? Why don't we add in just one more test? We'll call this one bland tax, and we'll say that one is $450. And this time round, per 3 months. Now my expectation per 3 months should be quarterly. So shift enter on that. Let's see how we go. Are we going to end on a high note? Yep, it's done it. That's very nice. That's very nice. Now it's added some funky stuff there. If you notice, when we did period and we got those different values, what we can actually do is maybe in the next video, or maybe I'll do it offline, whatever it is, cost type. That's currently a string. We're giving this LLM a lot of freedom to choose a value. We could quite easily define a nice long list of the different expenses we would expect to see and have it choose from one of those. There's pros and cons to doing that. There might be expenses that we weren't expecting, but we can just prompt around that. You know, if there's an other, let's bucket into that and then have it define what that other is. Look, I won't spend too much more time on this one. I'm very excited that we can get these, you know, what is essentially a tiny model, a 3 billion parameter model in the grand scheme of things, to take unstructured data that isn't all that clean. Oh, I did call it hash 450. That's because I didn't use a $sign. That was my fault. Okay, I'm very excited. I'm comfortable this time around. It's going to be perfect. If you haven't already, make sure you get into local large language models or online ones if you're happy to pay. But yeah, using this is just such a dream. Look, thank you so much for watching. If this is at all useful, please subscribe. It does help the channel. Give it a thumbs up, give it a like, drop a comment, say hello, ask questions. I'm always keen to help. Thanks so much.